हेलो डियर, आज हम लोग लिमिट्स की चर्चा करेंगे। जनरली हम लोग अपने भाषा में कहते हैं कि अपने लिमिट में रहो, लेकिन मैथमेटिक्स में इस लिमिट का क्या सेंस? तो लिमिट का शब्दार्थ है सीमा, अपनी सीमा। तो लिमिट्स हम लोग मैथमेटिक्स में भी एक सीमा के रूप में ही यूज करते हैं, लेकिन मैथमेटिकल टर्म में इसको हम लोग डिनोट करते हैं LIM और LIMIT और LT, और इसके नीचे कोई नंबर x टेंड्स टू 0। जैसे मैंने लिख दिया लिमिट x टेंड्स टू a, इसको हम लोग पढ़ेंगे x टेंड्स टू a, दैट इज x a की ओर अग्रसर, यानी x का हमारा सीमा हो गया a। इसको हम लोग डिफाइन कर रहे हैं, a number a is said to be the limit of any function f at point x बराबर a if and only if for any arbitrary chosen positive number epsilon, however small but not 0, there exists a corresponding number delta greater than 0 such that mod of f of x minus a less than epsilon for all values of x. For this x minus a mod is greater than 0 less than delta, where mod of x minus a means absolute value of x minus a. That means if we write mod of x but it gives us always positive, that means for x greater than equal 0 and x is less than 0. Here since x minus a must be gives us positive value. Its sign, if x is greater than, x will be greater than a, that means this term will be positive, x minus a less than delta. But if x is less than a, so in the modulus form that will be either like that this, but it always gives us positive value. So here a minus x must be less than delta. In other words, x is greater than a, then x is less than a plus delta, and if x is greater than a, then x is greater than a plus delta. Hence, mod of x minus a less than delta means x can be assigned any curve between a minus delta and a plus delta. The x lies between x is greater than a minus delta and x is less than a plus delta. So this is nothing but a minus delta and a plus delta are the neighborhood point of a. This is nothing but neighborhood point of a. तो कहने का सेंस यह हो गया, जैसे हम लोग एक घर बनाते, तो घर के चारों तरफ एक बाउंड्री देते हैं। तो बाउंड्री देने का सेंस ये है कि हमारा परिसीमा इस बाउंड्री के अंदर है, यानी उस बाउंड्री के अंदर या अप्रोच टू बाउंड्री। तो यह a माइनस डेल्टा एंड a प्लस डेल्टा, तो दिस इज नथिंग बट लाइक दैट दिस पॉइंट इज हियर a माइनस डेल्टा इज द लेफ्ट ऑफ a and a plus delta is the right of a. Now, how can we use limits over algebraic operation? First is addition. The limit of a sum is equal to the sum of the limits. If we write limit x tends to a f of x plus gx, this will be limit x tends to a f of x plus limit x tends to gx. If we write here f of x minus gx, then it gives us here negative form. Second, the limit of a product is equal to the product of the limits. Limit x tends to a fx into gx equal to limit x tends to fx into limit x tends to gx. The limit of a quotient, limit x tends to a fx by gx, this equal to limit x tends to a fx divided by limit x tends to a gx. If fx is less than gx for all x, then limit x tends to a fx must be less and equal limit x tends to a gx. If fx is less and equal gx for all x, then limit x tends to a fx less and equal limit x tends to a gx. If fx is less than fx is greater than gx but less than hx, and limit x tends to a gx is L, limit x tends to a of hx is L, then limit x tends to a fx equal to L. Now next is indeterminate form, that means that is the meaningless form. 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 1 raised to infinity, 0 raised to 0, and infinity raised to 0. If we have given limit x tends to a, x square minus 1 by x minus 1, we substitute here x equal to 1, then it gives us 1 minus 1 by 1 minus 1, that is the 0 by 0, and this is indeterminate form. This gives us not any value. Limit x tends to infinity log e raised to x by x, this gives us infinity by infinity. Limit x tends to 0, 1 plus x raised to 1 by x, and at x is equal to 0 we get 1 raised to infinity. But these all are the indeterminate form. Now some results we have to use to solve like that indeterminate form when we substitute the value of x. Then for solving these questions we have to use these results. First, e raised to x, this equal to 1 plus x, x square by factorial 2 plus x cube by factorial 3, and so on. E raised to minus x, this equal to 1 minus x plus x square by factorial 2 minus x cube by factorial 3, and so on. Log 1 plus x is x minus x square by 2 plus x cube by 3 minus dot dot. Log 1 minus x is minus x square by 2 minus x cube by 3 minus goes to infinity. Here 1 minus x, all terms be negative, but log 1 plus x, one term positive, another term negative, that is in alternate form. Sin x equal to x minus x cube by factorial 3 plus x raised to 5 by factorial 5 and minus so on. Cos x, 1 minus x square by factorial 2 plus x to the power 4 by factorial 4 minus dot dot infinite terms. 10x, x plus x cube by 3, 2 by 15, x to the power 5, and so on. Sin hyperbolic x, x cube by factorial 3 plus x raised to 5 by factorial 5 plus dot dot infinite terms. Cos hyperbolic x, 1 plus x square by factorial 2 plus x raised to 4 by factorial 4, and so on. A raised to x, this equal to e to the power x log a, and now we can expand using this result e to the power x. We get 1 plus x log a whole square by factorial 2 and dot dot. 1 plus x raised to n by binomial expansion, 1 plus nx, n minus 1 by factorial 2 x square, and so on. Last term will be x to the power n. 1 minus x raised to minus 1, that will be 1 plus x square plus x cube, and so on. 1 plus x raised to minus 1, 1 equal to 1 minus x plus x square minus x cube. Here 1 by 0 equal to infinity and 1 by infinity equal to 0. Now some trigonometrical result, limit theta tends to 0 equal to sin theta by theta, and limit theta tends to 0 tan theta by theta equal to 1. Some other results we have to use. Limit x tends to a, x raised to n minus a raised to n by x minus 1, x minus a, this equal to n, a raised to n minus 1. Here if we substitute x equal to a, this will be 0 by 0 form. Limit x tends to 0 log 1 plus x by x, this equal to 1. limit x tends to 0, e raised to x minus 1 by x equal to 1. Limit x tends to 0, e raised to x minus 1 by x equal to log a base c. Limit x tends to 0, e raised to ax minus 1 by x equal to a. Limit x tends to 0, e raised to ax minus e raised to bx by x equal to a minus b. Limit x tends to 0, a raised to x minus b raised to x by x. This will be log a by b. And these all are 0 by 0 form. Now limit x tends to 0, 1 plus x raised to 1 by x equal to e. And this is the form of 1 raised to infinity. If we substitute coefficient of x here a and here 1 by x coefficient b by c, then this will be e raised to ab by c. Now next, same generalized form of this 1 plus minus a into x raised to b by cx, and this also equal to like that e raised to minus ab by c. Other form of this question, limit x tends to infinity, 1 plus 1 by x raised to x is equal to e. Limit x tends to infinity, 1 plus a by bx raised to cx, and this equal to e raised to ac by b. Now we are going to solve one results. Limit theta tends to 0, sin theta by theta, limit theta tends to 0, tan theta equal to 1. Here we are taking, if theta is positive, theta lies between 0 to 90 degree. Now we draw a circle with center O and radius R. OA and OB are the radius. We expand OB and tangent from A. Both lines meet at point C. Here OB the center of circle whose radius is R. Now angle AOB, this angle AOB is theta. Radian, theta lies between 0 to 90. Tangent to the circle at point A which cut OB at point C. Now we draw a perpendicular line BD on the radius OA. Here OA equal to OB radius. Now area of triangle AOB, this equal to half base OA and perpendicular line, this is BD, height BD. Here 1 by 2 R into R sin theta, but BD is here R sin theta. How can we get the angle from triangle OBD? Triangle OBD, this is a right angle triangle and this is R, this distance is R. From triangle OBD, sin theta equal to BD, P by H OB, BD by OB, BD by R, and that gives us BD equal to R sin theta. Area of sector AOB, area of sector AOB, this whole sector, theta by 2 pi into pi r square, this equal to half r square theta. Now next triangle OAC, area of triangle AOC, this is the right angle triangle because this is the tangent, here angle will be 90 degree. The half into OA into AC. But AC, for here AC, how can we find? The triangle OAC, tan theta is AC by OA, AC by R, and that gives us AC equal to R tan theta. So here half into OA is R and AC is R tan theta. So that will be half R square tan theta. Now area of triangle OAB, this part is less than area of sector OAB. and this also less than area of triangle OEC. So here area of triangle AOB is less than area of sector AOB less than area of triangle AOC. This equal to half r square sine theta, half r square theta, and half r square tan theta. Here common term is half r square sine theta. We divided all terms half r square sine theta. 1 less than theta by sine theta less than 1 by cos theta. Now it's reciprocal. That means this inequality will be changed. If we write 2 is less than 3, 1 by 2, 1 by 3, which number will be greater? 1 by 2 is greater than 1 by 3. So here we write 1 is greater than sine theta by theta, greater than cos theta. Now taking limit theta tends to 0. Limit theta tends to 0, 1 greater than limit theta tends to 0 sine theta by theta, limit theta tends to 0 cos theta. Here we substitute theta is 0. That gives us 1 because cos 0 is 1. So 1 is greater than limit theta tends to 0 sine theta by theta greater than 1. Hence, it is only possible for limit theta tends to 0 sine theta by theta is 1. But how? Here we are saying that sine theta by theta is greater than 1. But sine theta by theta is less than 1. Is it possible? No. It is only limit theta tends to 0 sine theta by theta equal to 1. Now next, if we take theta is less than 0, let theta is minus theta, limit theta tends to 0 sine theta by theta, limit theta tends to 0 sine minus theta by minus. So sine minus theta is minus sine theta by minus theta, minus minus cancel, limit theta tends to 0 sine theta by theta, and this also equal to 1, previous result. Now limit theta tends to 0 tan theta by theta, limit theta tends to 0, we can write tan theta sine theta by cos theta into 1 by theta. Limit theta tends to 0 sine theta by theta into limit theta tends to 0 1 by cos theta, and this equal to 1, and cos 0 is also 1. So limit theta tends to 0 sine theta by theta, limit theta tends to 0 tan theta by theta equal to 1, and its generalized form is limit theta tends to 0 tan a theta by a theta is also equal to 1. Limit theta tends to 0 sine a theta by a theta equal to 1. Now next, limit x tends to a x raised to n minus a raised to n by x minus a is equal to n a raised to n minus 1. LHS limit x tends to n x raised to n minus a raised to n by x minus a. Let x equal to a plus h. If x tends to a, here x will be a equal to a plus h, and this equal to h barabar 0. So when x tends to a, then h tends to 0. Limit h tends to 0, here x is a plus h raised to n minus a raised to n divided by a plus h minus a cancel. Here we are taking a common, a with power a to the power n, a plus h raised to n. We are taking a common, 1 plus h by a and whole raised to n. So this will be a n 1 plus h by a raised to n. Here a raised to n into 1 plus h by a raised to n minus a raised to n by h. Whole terms we are taking common, a raised to n, 1 plus h by a raised to n minus 1 by h. Now here we are using binomial expansion. 1 plus n into h by a plus n minus 1 factorial 2 h square by a square, and up to last term will be h raised to n by a raised to n and minus 1 here. 1 cancel here, this one cancel. Now next will be n h by e, n minus 1 factorial 2 h square by a square up to h to the power n by a to the power n by h. Now we are taking common h by a from whole terms. So that will be a raised to n h by e into n plus n minus 1 factorial 2 h by, and up to last term will be h raised to n minus 1 by a raised to n minus 1 divided by n. This h cancel, a raised to, this time one term we cancel, here a raised to n minus 1, and now we substitute value of h equal to 0. So first term will be n and next term will be 0 0 0 0. So this gives us result n a raised to n minus 1. The second result is limit x tends to a, x to the power n minus a to the power n by x minus a, this equal to n a to the power n minus 1. Now next class we will discuss how can we solve the questions of limits using these previous results. Okay.